Right, hello again. What we're going to be looking at today is charts and tables. Why do we use these? So we use charts and tables when we've got a lot of information, a lot of data we're dealing with, and we need a nice, simple way of showing it off where we can find out things about it quickly without having to read through long lists of numbers like this, basically. They're there to make our life easier. We should already be familiar with some certain types of charts and tables, so we should have seen both of these before. Okay, so this is a bar chart, okay, and this one here is a pie chart. Both of these we should know before. Okay, now you'll be able to see, looking at these, that we could get some information really quickly, but the thing that's missing from them for us to get a lot of useful data from it is a key. So remember, a key is what tells us information about the chart. So here, if we look at both of these, we know that whatever is represented by the colour purple, there's more of that than anything else, but we don't know what that colour purple means because there's no key. So let's say then that these two charts, they're representing people's favourite sports. Then, if we made a key for that, we'd be able to get a little bit more information from the graphs. Okay, so if we say that purple, that equals shinty, blue equals football, green is tennis, and red is running. Now we can immediately tell by looking at these that more people prefer shinty to any other sport because it's got the bigger bar here and it's got the bigger section of the pie. We can see that the least favourite sport in this group of people was tennis, because that's a smaller part of the bar and the smallest piece of the pie. Okay, so bar charts and pie charts, they work best when you've got a small set of options. If you've only got 4 or 5 different options to choose from, you can show them really easily on a bar chart or a pie chart. If you've got a lot of different options, say 10, 15, 20 different options for something, bar charts and pie charts are going to get quite messy. Okay, and you need to be thinking of something else. And that's what we'll go on to later. What we are going to start this little lesson with, though, is something called a dot plot. Okay, we're not going to spend very long on this because, to be honest, a dot plot is just very, very similar to a bar chart. It's just another way of representing that information. And so, just like a bar chart, a dot plot is going to have 2 axes. So your axes are these things here and there. So your dot plot is going to have 2 of those. Okay, and we could label both of those. If we labelled this one sport, okay, and we'd put, let's put an S there for shinty, an F for football, a T for tennis, and an R for running. Okay, and then up this side you're going to have the amount. So let's just write amount there. You can't read that very clearly, but it's not too important for this. Okay, that says amount. Okay, and then so the next thing you have in a dot plot is each piece of data has its own dot. Okay, so we didn't use any numbers up here because we're just using them for examples of the types of chart, but let's say that this was 4 for football. So that means on football here we'd put 4 dots. 1, 2, 3, 4. Okay, say for tennis that was only 2 people, so it gets 2 dots. Say running was 4 as well. 1, 2, 3, 4. And let's say shinty was 7 people. So 1, 2, 3, 4, 5, 6, 7. That's a dot plot. So your final plot ends up looking very similar to a bar chart, but instead of there being solid bars, you've got instead columns of different numbers. Again, you can see straight away that shinty was the most popular, tennis was the least popular, but we don't need there to be any information on this side for us to see how many people liked everything. So if we look at this bar chart again, because there's no information on this side here, we know that people hated tennis, okay? Very few people liked it, but we don't know how many people that actually was. If we look at our dot plot, we know that that small amount of people liking tennis is actually 2 people. And we know that that loads of people liking shinty is 7 folk. Okay, so a dot plot is very similar to a bar chart, but it sort of condenses the information. Okay, so you can get numbers from it a wee bit easier without having to read values up the side. But whether you use a dot plot or a bar chart, it's kind of up to you, because again, they both only really work if you've got a few categories of something. If you're asking a question that can be split up into, say, 5 or 6 different answers. If you're trying to get some information that has a lot of different possible answers, that's when you want to start thinking about different types of chart and diagram. Okay, that's what we're going to be going on to now. So we're going to be looking at a slightly more complicated one. Okay, and we call that a stem and leaf diagram. Okay, so the key bit about a stem and leaf diagram, why it's important, is because it will tell us just as much information of these. We'll be able to very quickly look at it and see which choice was picked most, but we can use it to represent much more data. Okay. So a stem and leaf diagram doesn't have these axes like this, okay? Doesn't need labels or anything on axes. All it has is a line down the middle, okay? And this side of your line here, that is your stem, and this side of your line here is your leaf. The way a stem and leaf diagram works is we split it up, so we're looking at the data in different sort of ranges, okay? Different little sections of the information or the data. And let's say I asked you how far away from the school you lived. Some of you would give very small answers, like 1 kilometre, 2 kilometres. Some of you would give much bigger answers, like 50 kilometres, 40 kilometres. And we could put all those different values on this diagram. Okay, so down this side of your stem and leaf, then you're going to have here 0, 1, 2, 3, 4, and these stand for your tens. So a stem and leaf diagram is split up into tens on this side and units on this side. That's how most of them are split up. You could do something a wee bit different, but we don't need to worry about that. Okay, and so if, for example, I said someone lived 4 kilometres from the school, there's no tens involved in that, but there are 4 units. So we put a 4 there, and that means that person, that represents a person who lives 4 kilometres from the school. If there was a second person who also lived 4 kilometres from the school, we put another 4 there. If a person lived 5 kilometres, again, there's no tens involved in that, so we put a 5. We start using these other stems here when we've got bigger numbers. Say, for example, I lived 26 kilometres from the school. 26 has got 2 tens in it, so we're going to be in this stem here. And the units for the 26 is the 6. So that means I've got 2 tens and 6 units. That gives me 26. Just like in the charts we had here, bar and pie chart, we had a key. We always use a key for these diagrams as well. So let's write at the side here our key. Okay, and we're going to say for our key that if we've got the 2, then a line, and the 6, we're going to say that that equals 26. So let's just put down some random values that you could have on your stem and leaf diagram. Let's say we've got 7, 11, 21, 18, 35, 40, 35, and 18 again. Now, let's go through all of these. Let's deal with the 7 first. There's no 10s involved there, so it's going up on this one. And there's a 7, so we'll put that there. Okay. A key thing here for stem and leaf diagrams is that they need to be done in order. Okay, so your lower numbers, your 4s, have to be before the 5s and the 7s. Okay, which means when I go to fill in some of these are going to be lower than that 6, so I'll just cross that out for now. Okay, and let's pop a 26 on there, and we'll put that back in after. Okay, now let's look at the stem that involves one lot of 10s. So we're looking for any numbers that start with a 1. Okay, we've got 1 here, we've got an 11, we've got an 18, and we've got an 18. So there's going to be 3 numbers we write in here, and we'll start with the lowest one. So we've got an 11, that's 1 10 and 1 unit. So 1 10 and 1 unit. An 18, that's 1 10 and 8 units. So 1 10, 8 units. And then we've got another 18. So 1 10, and 8 units. Okay, then let's look at the 2s. So any number starting in a 2 now. So we have here, we've got 21 and we've got 26. Again, we're doing them in order. We start with the lowest one, so that's 21. 21 is 2 10s and 1 unit. 26 is 2 10s and 6 units. So we'll put a 6 there. Okay, next, anything starting with a 3. We've got 35 and 35. Okay, so 3 10s, so it's 35, and 5 units. We've got another one. Okay, so we'll just write another 5 like that next to it. Then finally, the only number we've got left is this 40. We know 40 has got 4 10s, so that's right, and it's got no individual units. Okay, now, this was a bit of an annoying set of data. Takes a wee minute to look through that, find out what the lowest one is, find out what the highest one is, okay, find out what the most common one is. We can see that much quicker now by looking at this. Obviously, it takes a wee bit of time for you to actually make that, but once you've made it and you show this to other people, it's much easier for them to get information from it. So, let's have a look. And we'll say, what range of times for someone to get, oh sorry, this was distances. What range of distances from school is the most common? And we can see, well, most people live less than 10 kilometers away, because we've got 4 values here in this 0 to 10 range. And we'll say the least amount of people live 40 or more kilometers away, because we've only got 1 value here in this range that represents 40. And we can look at this and see our lowest value. So our lowest value is going to be the top left one, because the lower ones are at the top and you start with the lowest number on the left. So this one here, your top left value, that will always be your lowest, okay? So your lowest value is always the top left. Okay, so our lowest value here is 4. Okay, our highest value, where do we want to look on here for the highest value? So the highest value is going to be in the bottom row, and it's going to be the furthest along that bottom row. So our highest value is opposite of the lowest, is the bottom right. All right, move it over a wee bit. So if we look at this, our bottom right number is 40. So our highest value is 40. Okay? We could even look for things like the most common value, and we could see here, oh, there's 2 people who live 4 kilometers away. There's 2 people who live 35. There's 2 who live 18. So there's a couple of common values there. So just from this little stem and leaf diagram here, we can get a lot of information really quickly. The best thing it helps us find out is we can immediately spot the lowest value and the highest value, and we can immediately spot which range has the most values in. So let's look at a question then that's actually going to use this. So let's look at this question here. Okay, so pupils were asked how long they spent on homework each night. Then they gave these answers. So their answers were 30, 31, 9, 11, 3, 13, 13, 21, 18, 42, 27, 13, 27, 58, 61, 5, 27, 9, 14, 13, 32 and 35. That was annoying, okay? It's annoying to write, it's annoying to read through. That's why we have bars and charts, so it doesn't take that time to read through it all or write it all out, so we can get that information really quickly. So, first question, part A, construct a stem and leaf diagram of this data. Okay, so let's do that. Okay, our stem and leaf diagram is going to have a line down here. Oh, did not realise that was the green pen. Where's my black pen gone? Here. And let's say that this side of it is the stem. Stem is always this side. This side is the leaf. So your stem needs to have the starting numbers for everything. Okay, remember your stem is your tens. So we need to account for something that's got no tens and only units. We need to account for something that's got 1 10, so that's anything from 10 to 19. Anything with 2 tens, so 20 to 29. Anything with 3 tens, 4, 5, and 6. And let me just draw that green line a wee bit longer to fill that in. Okay, so this then is going to account for every little bit of information. And we just simply go through them and see what we have. So first, we're going to look for anything that's got no tens and just has units, okay? So there, we've got this number. 9 has got no tens. 3, 5, 9. Okay, now remember, we have to write these in order, starting with the lowest. So the lowest of those is 3. The next one is 5. Then we've got a 9 and we've got another 9. Okay, so you should always only be putting single digits here. Okay, there should be never a case where you have to write a double digit number here. And now we've filled out a little bit of that, remember, we need our key. So let's put a key and let's say that 0 line 3 equals 3. Okay, and again, we'll just go through and we'll do each of these. So now we're looking for tens, anything with 1 10 in it. Here we've got, and actually I'm going to use a different colour to make this clearer. We've got 11, 13, 13, 18, 13, and 13. And so again, we need to do these in order, starting with the lowest. So our lowest of those was 11, so that's 110 and 1 unit. Next, we've got 1, 2, 3, 4 13s. So we're going to write 4 3s down. Okay? That's saying we've got 1 13, another 13, another 13, and another 13. Then last in that one, we had an 18. So we'll write an 8, because 110 and 8 units is 18. Okay, next, let's look at anything with 2 10s in it. So we've got 21, 27, 27, 27. Again, starting with the lowest, we've got 21, so we'll put a 1 there, and then we've got 3 lots of 27, so we've got a 7, a 7, and a 7. Okay, next we're looking at the 3s, okay, we've got 1 there with 3 10s, 2, 3, and 4. And I have just noticed that back here, I made a little mistake, okay? And I didn't spot that 14 there when I was going through. So this is an example. You need to be really careful and make sure you're actually spotting every number, okay? I didn't spot that 14, so this belongs in this stem here, okay? But they have to be done in order. So we need to squeeze a little 4 in there because 14 comes between 13 and 18. Okay, right, let's get back to our ones with 3 10s in. Make sure we've got them all this time. We've got 30, 31, 32, 35. So here we've got 30, 3, 0. We've got 31, 3, 1. We've got 32, 3, 2. We've got 35, 3, 5. Okay? Now, it does take a wee bit of time actually making these, which is the downside. Okay, but remember, we're making these so we can share the information with someone else much easier, so they don't have to go through this. So we're being nice, we're being selfless. So now let's look at the ones with 4s. I don't have any different colours, so I'm just going to underline them. So we've got there a 42. That's it. So 4, 2. Now let's look at the 5s. We've got a 58. Again, that's the only one. So let's write an 8. And then we've got a 61. So let's write a 1 there. Okay, that's us finished our stem and leaf diagram. Okay, so instead of having this long track of all these numbers, we've represented that with this table here, which can tell us a lot more information about it. And so then let's look at that. Question B, what were the shortest and longest times? So remember, your lowest values are the top left and your highest values are the bottom right. So for the shortest, that's our top left number here, 3 minutes, or is it minutes? Our longest time is the bottom down here, bottom right, 61. Okay? That'd have been a bit more annoying to find after going through this. You have to search, right, okay, I've got 3. Let me keep going to see if I've got any lower than 3, or I haven't got any lower than 3. Okay, right. Let's find the highest one. Okay, I've got 31. Do I have anything higher? Oh, I've got something higher, 42. Okay, I need to keep looking to see if I have anything higher. Okay, and it takes you a while to get to it. If you look at this, oh, my lowest is this one, my highest is that one. Nice and easy. Okay. It can also tell us a wee bit more information. If I asked you what length of time from like 0 to 10 minutes, 10 to 20, 20 to 30, did most people spend doing their homework, you could say, oh, okay, that's obvious. It's a 10 to 20 minutes because that one has the longest leaf by a long way, okay? And we can see that way less people spend 40 or 50 or 60 minutes doing their homework because they've only got one thing in their leaf. Okay, now this last question I'm going to leave with you, and I want you to have a little think about it, and I'll address it at the start of the next video. But my question to you is, what problems are there with this data? So this is the information I've given you. I've said pupils were asked how long they spent on homework each night. These were their answers they gave. And so I want you to have a little think about, for the next video, what problems are there with that data. Okay, so keep that in mind, keep having a wee think about it. And that's us for this video, so goodbye.